Hello friends, very good morning to all of you. I'm your host Dr. Suman Kulkarni and you are watching our channel Genius Structures. I'm very happy to bring you the fourth session in the series of Mission Gate 2021. Today we are going to see and discuss the multiple choice questions that may be probably asked in Gate 2021. So friends, let us start with the multiple choice questions. First question is number of simultaneous equations to be solved in the slope deflection method is equal to, there are four options, static indeterminacy, kinematic indeterminacy, number of joint displacements in the structure, and none of the above. So the answer is kinematic indeterminacy. So you already know we calculate the kinematic indeterminacy, number of unknown displacement quantities in the beginning of any slope deflection method problem. So the answer is B, kinematic indeterminacy. Second question, slope deflection equation for moment at a support with sinking and without sinking is always same, different, not valid, none of the above. So the answer is B, it has to be different, because when you are going to consider the effect of sinking, 6ci delta by L square is the moment because of sinking, and when there is no sinking, delta will be 0. So obviously this term 6ci delta upon L square will become 0. Okay, let us move to third question. For solving an indeterminate beam by slope deflection method, degree of dash indeterminacy is required. Option A, static. Option B, kinematic. Option C, both. Option D, none of the above. So just discussed in two questions before, answer has to be kinematic indeterminacy. Next question, fixed end moment at a support due to sinking is 6ci by delta by L square. Okay, so option A is correct. It can be negative or positive, so only the determinant is asked. So fixed end moment value will be 6ci delta by L square. Next question, for a two span beam ABC, support B sinks down. Okay, so AB and BC, there are two spans and these are connected together to form one continuous beam. In this, support B sinks down. So fixed end moment at B due to sinking of B for span AB and BC is same, different, opposite to each other, both B and C. A little bit confusing question, and options also. Question is straightforward, simple, but options are a little bit confusing. So there are two options, B as well as C. Okay, both are correct. So last option you will be giving its answer as, because in AB span on joint B, fixed end moment due to sinking will be minus 6ci delta by L square, and at the same joint in span BC it will be plus, okay, plus 6ci delta by L square. So they are different, one is plus, another is minus, and they are opposite to each other also. So options B as well as C both are correct. Okay, so option D is the correct answer. Next question, for a symmetric fixed beam of span L subjected to UDL throughout, zero shear force will occur at dash from any support. So beam is simply fixed end, not simply supported. Beam is fixed beam. It is symmetric geometrically as well as it is symmetric loading wise. So obviously point of zero shear force has to be at the center from the ends, any of the ends. So L by 2 is the answer if L is the span. So answer C is correct. Next question, for a symmetric fixed beam of span L subjected to UDL throughout, maximum bending moment will occur at dash from any support. So when zero shear force is there, there has to be maximum bending moment. So we have just now discussed that zero shear force will occur at L by 2. So obviously maximum bending moment will also occur at L by 2 from any of the spans, provided The beam is geometrically symmetric as well as loading wise also it is symmetric. Next question. Slope deflection equation contains moments due to external loads, sinking of supports, and there are 4 options: joint rotation, member rotation, both A and B, none of the above. So if you remember what is slope deflection equation, so there is 2ei by L inside the bracket, 2 theta A plus theta B minus 3 delta by L outside the bracket, minus MFAB and plus MFAB. So last term MFAB or plus or minus, these are moments due to external load, which are fixed end moments. Then coming to first term, 2ei by L into bracket theta A plus theta B. These two are moments because of rotation, and minus 3 delta by L is the last term in that square bracket. So 3 delta by L into 2ei by L, it is 6ei delta by L square. So it is moment due to sinking. So third option, the third moment which is not included in this sentence is moment due to rotations, joint rotations. So option A is correct. Now let us go to next question. For a propped cantilever beam subjected to clockwise moment M on propped end, moment in terms of rotation is, so it is a standard result, propped cantilever beam subjected to clockwise couple on propped end. So there if end B is the propped end and theta B is the rotation, or theta is the rotation on that particular joint, then 4ei theta by L is the moment induced on that end in terms of rotation of the joint. So option B is correct. Next, for a propped cantilever beam subjected to clockwise moment on fixed end, not fixed end, it is propped end, moment in terms of rotation is 2ei theta by L. So moment on propped end is 4ei theta by L. So moment M on fixed end, yes, I will correct myself. Moment on fixed end we have been asked. So moment on propped end is 4ei by theta by L, that is correct. Its half value will be carried over to fixed end. So 2ei theta by L is the correct answer, option D. Okay, question is also correct. Next question we will see. For a simply supported beam subjected to clockwise moment M on any end, moment in terms of rotation on that end is, there are 4 options again: 3ei theta by L, 4ei theta by L, 6ei theta by L and 2ei theta by L. So option A is correct. The boundary condition is changed. It is no more a propped cantilever beam, it is simply supported beam subjected to a clockwise couple on any one of the ends. So wherever that moment M is acting on that end, moment induced will be 3ei theta upon L. Next question. For a simply supported beam AB subjected to clockwise moment M on end B, moment in terms of rotation on end A is 0. Okay, why 0? Because end A is simply supported end, it is not subjected to any external loading. So simply supported end, we already know, or always moment for this end is 0. Okay, so option B is correct, 0. Next question. For a fixed beam AB with no external loading and sinking of support B downwards, fixed end moment is, there are again 4 options: 0, non-zero, cannot say, both A and B. So cannot say is not an option, correct option. Both A and B at the same time moment cannot be 0 and non-zero. So only 2 alternatives are there, either 0 or non-zero. So moment has to be non-zero. Even though there is no external loading on the beam, there is effect of sinking of support, which will induce moment of magnitude 6 ei delta upon L square. So it will be minus depending on, minus or plus depending on whether the relative sinking of that support is down or below. So here it is downward with respect to A, so on end A as well as B, fixed end moment due to sinking is minus, which is non-zero. So option B is correct. Okay. Next question. Slope deflection method was introduced by, many times we see various questions, deep study on slope deflection method, but we do not know who has invented this method. So there are four options: George A. Manny, Hardy Cross, Duncan, none of the above. So three different scientists have invented three different methods which are very popular today. So George A. Manny is the correct answer, who invented slope deflection method. Hardy Cross is the scientist who invented moment distribution method. Duncan is the author who invented stiffness matrix method, which is now also known as direct stiffness matrix method. So direct stiffness approach. So friends, one more question. Slope deflection method is used for the analysis of option A, indeterminate beams only, indeterminate frames only, both A and B, none of these. So option C is correct. We can solve indeterminate beams as well as indeterminate frames using slope deflection method. So friends, these are my important questions that I felt are a little bit tricky and can be asked in the GATE 2021 examination. So friends, if you are new to this channel, do subscribe my channel, and if you have not understood any of the questions, you please refer my all the videos on slope deflection method, wherein I have in detail explained the derivation of slope deflection equation, the derivations for standard cases like propped cantilever beam, also simply supported beam, and I have carried out the analysis of different varieties of beam problems as well as portal frames. So friends, thank you very much. If you have any questions, do write in the comment section. Thank you.